Now we'll turn MLOps theory into practice. We'll train a simple model, capture parameters and metrics, save artifacts, and track versions, so the work is repeatable and ready for packaging and deployment next. We've already built the foundation: what MLOps is, where DevOps skills fit, and how the ML lifecycle works. This module shifts from concepts to execution as we build, evaluate, and track a simple model workflow. In MLOps, deployment is not the starting point. The workflow begins when raw data and experiments become a trained model artifact. But that artifact is only useful if we also capture the recipe behind it: the data version, parameters, metrics, code, and environment. Tracking helps teams compare runs instead of relying on memory. Reproducibility makes failures easier to debug, results easier to audit, and improvements easier to repeat later. Let's make the workflow concrete with customer churn. A business wants to predict whether a customer is likely to leave. The model might use tenure, monthly charges, contract type, support calls, and payment method. The output is simple: stay or leave. That prediction helps teams focus retention efforts on customers who may need attention before they cancel. Before training a model, we need to understand what the data is telling us. The target variable is the outcome we want to predict, such as whether a customer churned. The features are the inputs that may help explain that outcome, like tenure, contract type, or monthly charges. We also check data types, because numbers, categories, text, and true-false fields need different treatment. Finally, we look for quality issues early, including missing values, duplicates, and inconsistent formats. Once the data is understood, define the prediction task clearly. Will this customer churn? Yes or no? That makes churn a binary classification problem. But success is not just high accuracy. Accuracy asks how often the model is right overall. Precision asks whether customers flagged as churners truly churn. Recall asks whether we found the churners who actually existed. F1 score balances precision and recall when both matter. The right metric depends on the business cost: wasting retention offers or missing customers who are about to leave. A training workflow is a chain of handoffs. First, load the dataset and inspect it so you understand the columns, missing values, and target labels. Then preprocess by cleaning records, encoding categories, and scaling features when needed. Next, split the data, train a baseline model, and evaluate it with metrics that match the task. Finally, save the trained artifact, such as a model.pkl, so it can be reused outside the notebook. The first executable step is getting the data into a form Python can work with. In pandas, that often starts with read CSV, followed by quick checks like head, info, missing value counts, and value counts for the target column. These checks answer practical questions. What columns exist? Are the data types sensible? What values are missing? Is the target balanced? Record assumptions now, because reproducibility starts before modeling. Before a model can learn, the data needs to be made model-ready. Missing values are handled in a way that fits the business context, either by filling them or removing records. Categories like contract type are converted into numbers. Predictive fields are kept, while identifiers like customer ID are dropped because they only label a row. Most importantly, the exact same preprocessing must run during training and later when new customers are scored. To know whether a model will work beyond the data it has already seen, we keep part of the dataset hidden. The training set is like practice material. The model studies it and learns patterns. The test set is more like an exam. It checks whether those patterns generalize to new examples. An 80-20th split is common, though 70-30th can also work. Setting a random seed makes the same split repeatable every time. Before reaching for advanced algorithms, create a simple baseline. In scikit-learn, that usually means choosing a model like logistic regression, a decision tree, or a random forest, then calling fit on the training features and labels. The fitted model has learned patterns from the historical churn data. Then use predict on the test set to generate churn predictions. This first score becomes your reference point, so every later improvement has something concrete to beat. After training, we move from building the model to judging whether it is useful. Test data gives an honest check on examples the model has not seen before. For churn, Accuracy alone is not enough. Precision shows how reliable the churn flags are, recall shows how many true churners we catch, and F1 balances the two. We compare these results with a baseline or business target, decide whether to improve, package, or deploy, and record the outcome. The trained model should not stay trapped inside a notebook or script. Save it as a model artifact, such as a PKL, joblib, or framework-specific file. That artifact is the reusable output of training. Include the supporting details too: pre-processing logic, parameters, metrics, dataset reference, environment information, model name, version, and training date. Together, these details make the model traceable, repeatable, and ready to become the input for packaging, testing, and deployment. Experiment tracking turns training from a one-off activity into a reproducible process. Each run records the choices you made, such as model type, hyperparameters, and pre-processing. It also logs performance metrics and stores artifacts like model files, charts, and reports. MLflow connects these pieces so teams can compare runs objectively. Once a candidate performs well, the model registry labels its version and stage, making it clear what is experimental, tested, or ready for production. You now have the core MLOps foundation for a repeatable model workflow: loading data, pre-processing, training, evaluating, tracking metrics, and saving a model artifact. From here, that artifact becomes a deployable service. Next, we'll expose it through an API, package it with Docker, and prepare for CI/CD, monitoring, and retraining.